All right, so let's go ahead and get started. So I'll bring over my OneNote page here. So we're talking about polynomial functions. Again, the last thing we looked at were linear functions. Linear functions are a particular kind of polynomial. So we've already had some exposure, but polynomials are much more general. Basically, you can string together real numbers multiplied with, variables to any non-negative integer power and add and subtract those terms together. So, they can be, as long as they're finite in length, that's what makes them a polynomial. So we'll start with the definition. It'll look technical, but you're probably much better at identifying polynomials than you realize. So a polynomial function is one that has the form so again, say f of x is, we've got a bunch of indices here, a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, and then a bunch more terms. And then we have our remaining a sub 1x plus a sub 0, where x is the independent variable. N is a non-negative integer. And all those a's with the subindices are real numbers. So a sub n all the way through to a sub 0 are real numbers. So there's still even more terminology. So we've got names for a lot of special parts of these terms. We say n is the degree. So the highest power of x that you see is the degree of the polynomial. So n is the degree what else? We call a sub n the coefficient of the very first term we see. That's known as the leading coefficient. So a sub n is the leading coefficient. And a sub 0 is known as the constant term. So the first thing we'll look at, well, I'll just show you a bunch of examples and we'll try and decide if they're polynomials. So where can things go wrong? So example, is the given function polynomial? If so, identify the degree. I don't know, why don't we start with maybe something like f of x is 12x to the fifth minus 11x plus the square root of 2. So is this a polynomial? Well, the only thing you need to check is, does the x's, do they have non-negative powers, 5 and 1, and then a constant term? So that checks out. And are the numbers in front real numbers? They sure are. So it checks out. So this This one is a yes. And we would say the degree, the highest power is 5 here. Part B, let's say we have g of x, and that's maybe, I don't know, let's say 9x cubed minus 8 plus 17 divided by x. So this one is actually a no. And why is it a no? Well, we didn't really say anything about dividing by x. If you divide by x, that can be rewritten using exponent rules as a negative power. So that's why this is going to be a no. I'm going to say no. 17 over x can actually be rewritten as 17x to the negative first, and negative powers of x are not allowed. Then we'll move on to another one. Let's say we have h of x is 7x squared minus 10 square root x. Now this one's also going to be a no. And you might be confused because you might look at A and say, well, that was a polynomial. What's the difference? Well, the difference is what you're taking the square root of. The square root of 2 is just a number. It's an irrational number, sure, but it's still a real number. When you're taking the square root of x, you're messing with a variable. And that is a fractional exponent. So you cannot have a fractional power of x either. So I would say no here. And the reason being, 10 square root x is really the same thing as 10 times x to the 1/2 power. And let's say fractional powers of x are not allowed. Remember, the only acceptable powers for x are non-negative integers. So if you have negative values like in part B, that disqualifies it, and the same as C. Okay, what about D? Let's say we do something like C of x is equal to, I don't know, let's say 6. Would this be a polynomial? It's a constant function. So, in fact, it is a polynomial. It might surprise you. What would we say the degree is? We don't see any x's anywhere. Well, you could kind of think of it as 6x to the 0, because x to the 0 is just equal to 1. So for that reason, when we have a constant term, it is a polynomial, and we would say the degree is equal to 0. And then maybe we'll look at one more. Maybe, let's say f of x is 5 to the 2x plus 1. This looks completely different than all the polynomial things because we have a variable in the exponent now. So that's not allowed. This function is exponential in nature. So that's a class of functions we'll come to after polynomials. So I'm just going to say no, a variable and the exponent is not allowed. So all set there. So now let's, we talked about linear functions. Let's move on to the second class of polynomials we understand the best, the quadratics. So we'll probably spend most of today on quadratic functions. If you came from college algebra, you spent quite a bit of time on these. As well, I'm sure you did in high school. So quadratic functions are just a fancy word for polynomial functions with degree 2. Got my N and my M confused there. So the general form is just f of x equals ax squared plus bx plus c. So your a, b, and c are just representing the constants, right? If we wrote it the way that we did for the definition, it would be a2x squared plus a1x plus a0. But usually when you have just a handful of terms, usually you just, instead of indexing the variable, what you do is you just use different letters. Okay, so similar to linear functions, you'd like a way to be able to graph these things rather quickly. You'd also like to find the equation in certain cases. You'd like to be able to solve for the intercepts. So we're going to do all of those things. So the first thing is, how do we graph a quadratic function quickly? That's taken care of by the vertex formula. So the vertex formula, what does it say? It says the vertex, which is, right, a parabola of the graph of a quadratic function is a parabola, and it's either opening upward or downward. So it's going to have either a highest point or a lowest point. That is called the vertex. Just as a quick refresher. So the vertex of a parabola occurs at x equals minus b divided by 2a. Now, a vertex should have two coordinates, an x coordinate and a y coordinate, but the formula for the y coordinate would be very confusing and not worth committing to memory. So for that reason, what we usually do is we just find the x coordinate using the simple formula, and then we plug that in to find the y value. So let's go ahead and make use of this via an example. So let's go ahead and sketch a graph of, let's say, y equals x squared minus 4x plus 2. So again, if you're identifying your terms here, a is the number that's with x squared, that's 1. B is the number with the x, which is minus 4. C isn't used in the formula, but we can write it down anyway. C is 2 here. So the let's just kind of an aside to identify the variables. So our x coordinate is equal to minus negative 4 divided by 2 times 1. So that's positive 4 over 2, which just comes out to 2. Then what we want to do is we want to find the y coordinate. So we plug that 2 into the formula. So we would have 2 squared minus 4 times 2 plus 2. So this comes out to negative 2. 4 minus 8 plus 2. So my vertex is 2 comma minus 2. So that's how we found the vertex. So let's go ahead and make a graph and sketch it there. At least find the vertex. So let's see, we have 1, 2, 3, 4, and then how far down we need to go. So our vertex is at 2, negative 2. This point right here. So the thing about a parabola is it's going to be symmetric through what's known as the axis of symmetry. So this dotted line, the dotted vertical line that would pass through the vertex is known as the axis of symmetry. So if we can find one more point, we can pretty much get a decent sketch of this parabola. The easiest point's the y-intercept, right? How do you find the y-intercept? Well, you just plug in 0 for x. And if you plug in 0 for x, the x squared goes away, the minus 4x goes away, and we're just left with that 2. So the y-intercept is going to be 0, 2. That's where it hits the y-axis, right here. And then from there, we can use symmetry to find a third point. So 2 steps left of the dotted line, we're at the y-intercept of 2. So if you go 2 steps to the right, you'll also be at a height of 2. So this is how we get our parabola. So that's a quick, easy sketch. And it goes through the points as such. I will say one thing to remember, when you're looking at a parabola, if you want to figure out if it opens upward or downward, that's all you need to do is look at the leading coefficient, so the number in front of x squared. If it's positive, it goes up. So in this case, a was equal to 1, the parabola opened up. If it were negative, it would open downward. So let's do another example where that leading coefficient happens to be negative. Excuse me. So example, let's go ahead and sketch a graph. Of, I don't know, y equals minus 3x squared plus 6x minus 4. So again, we're going to go through the same steps. Again, we can quickly identify a is negative 3 in this case, b is 6, and c is minus 4. So those are the identification of all of the constant terms. So let's find the x-coordinate of the vertex. That's going to be minus b, so minus 6 divided by 2 times negative 3. Comes out to negative 6 over negative 6, which is 1. Then we want to plug that into the y value. So plug that in for x. Negative 3 times 1 squared plus 6 times 1 minus 4. So we end up with negative 1 here. So our vertex, in this case, is positive 1 comma negative 1. Again, probably we're going to need the y-intercept as well. So the y-intercept, if you plug in 0 for x, you're just left with that constant term, which is negative 4. So you get 0 comma negative 4. Okay, then we should be ready to graph. So 2, and then we got. So our y-intercept is at 0, negative 4. Our vertex is at 1, negative 1. Right here. So again, this is our axis of symmetry. Our y-intercept is here. So that means to one step left, we're at a y value of negative 4. So one step right will be the y value of negative 4. And our parabola just goes through these 3 points. So that is the graph there. Just a nice upside down parabola. And we did it using 3 points very, very rapidly. Okay, so let me check and see if there are any questions to this point. Any questions from anyone? Go ahead and ask them in chat if you'd like. Or unmute yourself, up to you. Okay. So let's continue moving forward. Let's look at solving quadratic equations. So this is where we'll spend the rest of today. So solving quadratic equations. So there are 3 techniques that we will utilize. So the first one I'm calling the square root principle. The second is factoring. And the third is the quadratic formula. So what does the square root principle say? The square root principle just solves a very simple form of a quadratic equation. So basically, if k is a number greater than or equal to 0, again, you could do this with any value, but then you'd introduce complex numbers. And for this class, we're primarily focused on real numbers. So, and let's say we have some algebraic expression, a squared is equal to k. Then that equation can be simplified to two equations. A is equal to either plus or minus the square root of k. That's all the square root principle says. If you have something like x squared equals 9, then the answer would be x is plus or minus the square root of 9, which is 3. So that would have two solutions, 3 and negative 3. So let's go ahead and solve a couple of these. Let's go ahead and solve. So let's say we have x squared equals, I don't know, 256. Then we know x is plus or minus the square root of 256. So x is going to be plus or minus 16. Those would be your two answers. Part B, why don't we say maybe 16x squared is equal to 49. So the first thing is to go ahead and isolate that x squared. So we would start by dividing both sides by 16. So we would have 16x squared over 16 is 49 over 16. So then we would have x squared as 49 over 16. So at this point, we can apply the square root principle. So we know x would be plus or minus the square root of 49 over 16. So x would be either plus or minus 7 over 4. And that would be our answer for part B. Again, this rule, it doesn't actually just have to be x squared either. We could have something more complicated, an algebraic expression, let's say. So let's suppose we had, I don't know, somehow we had a polynomial factored into 3x plus 1 squared, and say that's equal to 225. We can actually think of that that we were using as the whole algebraic expression 3x plus 1 here. So we can use the square root principle right away and say, okay, well, 3x plus 1 is either plus or minus the square root of 225. So this would split into two equations that we could solve. 3x plus 1 is negative 15, or 3x plus 1 is positive 15, because the square root of 225 is 15. So solving this, we just subtract 1 on both sides and then divide by 3. So we have 3x equals minus 16, or 3x equals 14. Divide by 3, we get our two answers. X equals minus 16 over 3, or x equals 14 over 3. Okay, so that is the square root principle. Very simple, but very effective. Allows you to solve those types of equations very quickly. And it's actually used in conjunction with factoring to help arrive at the quadratic formula. Okay, so let's move into factoring. Factoring basically falls into two cases, an easy case and a hard case. So part 2, factoring. So basically what we're trying to factor, we're factoring something that looks like ax squared plus bx plus c equals 0. And there are the two cases. You've got one case where that leading coefficient is equal to 1. I would call this the easy case or the shorter case. And case 2, we would have a different from 1. So this is the hard case. It's not really too much harder. It just takes, I would say, 2 more steps. So let's go ahead and just learn by doing. So in the example, let's say we wanted to solve by factoring. So let's say we have something like x squared minus 13x plus 42 equals 0. So we want to factor this. Again, it's just x squared, so that makes this the easy case. That's where we're going to start. That's all you have to do when it starts with an x squared and not another number in front. We just look at this 42, this number right here. And we need to ask, we need to answer this question. So what two numbers multiply to 42 and add to the middle number negative 13? So it has to do both of those things simultaneously. And there's all kinds of numbers that multiply to 42, right? 2 times 21. But if you add those together, you get 23. So that doesn't work. What does work, some combination of 6 and 7. You might try 6 and 7. But if you do 6 and 7, those add up to positive 13. And we want negative 13. Well, you can get to that point by just making both of those numbers negative. Negative 6 times negative 7 multiply to positive 42. Well, when you add them, then they add to negative 13. So usually this is just done by trial and error mentally. So negative 6 and negative 7 do the job, and then that tells us exactly how we factor. So we'd have x minus 6 times x minus 7 equal to 0. And the nice thing about factoring it is now we have a product of two things that multiply to 0. And the only way that can happen is if one of those objects happens to be 0. So basically this tells me x minus 6 equals 0 or x minus 7 equals 0. So you have your two answers, x equals 6 or x equals 7. And that's that. So were there any questions on the factoring? Anybody have any problems on that example? So factoring is going to be pretty repetitive, but you really need to master it. Otherwise, you're going to struggle with a lot of the concepts later in the course. So if you took factoring lightly in the past, I would say just try and buckle down and go through the examples. Okay, so let's go ahead and do another one. Let's say B. Let's say we have x squared plus 21x minus 72 equals 0. So again, we're looking at this minus 72 and this 21. So minus 72, what are two numbers that are going to do the trick? Well, 24 and negative 3. 24 minus 3 adds up to 21. And 24 times negative 3 is minus 72. So that's how they factor. X plus 24 and x minus 3. So either x plus 24 equals 0 or x minus 3 equals 0, which gives us our two answers, x equals minus 24 or x equals 3. Okay, so probably we should do some examples just to make sure everyone's getting the hang of it. So let me write down 4 examples, and then we'll do a little breakout session, do those, and then come back and do the grouping method. So example, so let's say, again, just solve each by factoring. So let's say we have x squared minus 10x minus 144 equals 0. B. Let's say we have x squared let's say x squared plus 40x plus 256 equals 0. C, let's say we have x squared let's say minus 7x minus 120 equals 0, and maybe x squared plus 26x plus 168 equals 0. So I will split everyone into 4 smaller groups, and you guys can work on these for maybe 5 minutes, and then we'll go over the answers, and then probably we'll see if we can do an example on the grouping method for the harder case. If we don't have enough time, that's okay. Okay, so let's see. Okay, so all right, so I'm going to start these breakout sessions. So Isabella, Josh, Mandy, Nicholas, Sarah, you'll have A, Jacob, Lucas, Mackenzie, Sam, and Sydney. You'll have B, Arik, Cameron, Evan, Fred, and Annie. You'll have C, and Leah, Ravi, Robert, Aiden, and Richard, you will have D. So basically, breakout session 1 should get A, 2, B, C, 3, and 4D. So, okay, you should be in your breakout sessions, and I will go ahead and leave these.
Okay, so why don't I hop in and we'll see how people have done. Hop into some of these breakout sessions. Last class, there was a problem after I ended the breakout sessions. Is my screen still visible? Can someone just let me know in chat? Okay. Well, I'm going to go ahead and move on. Please let me know if you can't see my screen, and I'll leave the meeting and set that up again. But I want to move on to the second
type of factoring, factoring when the leading coefficient is not 1. And what I use here is the grouping method. There are many methods that are taught nowadays, but I think this is the most popular. If you use a different method, that is fine by me. So let's again just learn by doing some examples. So let's say we want to factor here. So part A, we have, let's say 5x squared minus 22x minus 15 equals 0. So we're going to use the same sort of thing, but when your first number is not 1, what you have to do is you actually have to multiply the first number by the third number. So we start by doing 5 times negative 15, which leaves me with minus 75.
Oh, we can't see the screen.
Okay, yeah, no one said anything before, so I don't know why this happens sometimes, but I'm going to have to leave the meeting and come back real quick. That's the only way I was fixing it before. So I'm going to make somebody the host for 1 second. All right, so I'm back, so hopefully it'll work now. Somehow the screen sharing crashes whenever I do the breakout meetings. Okay, so hopefully we are good now. Please let me know if you can't see, but I think you should be able to. So again, we're looking at this example, and the 5x squared minus 22x minus 15, we multiply the first and last, 5 times negative 15 to get this number negative 17. Now we want to find numbers that multiply to negative 75, but add to the middle number still negative 22. So in that case, 20 minus 25 and positive 3 will do the job. So here's where this one gets a little more complicated. We're going to rewrite 20 minus 22x as minus 25x plus 3x. And that's what we're going to replace minus 22x by. So we end up with 5x squared minus 25x plus 3x minus 15. And that's where the grouping comes from. We essentially form 2 groups, the 5x squared minus the 25x and the 3x minus the 15. So we've got group 1, group 2, and we're just looking for the greatest common factor to take out of each one. So the first group I can take out of 5x, and I know 5x times x makes 5x squared, and 5x times minus 5 will make minus 25x. Then the second group, I can just take out a 3. 3 times x makes 3x, and 3 times 5 makes 15. And now the x minus 5 is a common factor. So I can take out the x minus 5, and I'll just be left with the numbers in front. 5x plus 3. And now I'm completely factored, and I can use those factors to solve. So I have either x minus 5 equals 0, or 5x minus 3 equals 0. 5x plus 3, rather. And you can find the answers rather quickly. X is 5, or x is minus 3 over 5. So essentially, we've added kind of 2 more steps in the middle there where we group things. So let's see, we have, starting my time, we got 4 minutes left. Let's try and do one more, and then we'll start fresh with this next time. So let's go through B, say 3x squared plus 17x plus 24 equals 0. So we start by multiplying the first number 3 by the last number 24. So 3 times 24 is 72. 8 times 9 is 72, and 8 plus 9 is 17. So 8 and 9 will work. We rewrite this as 3x squared plus 8x plus 9x plus 24. Now we have our two groups, 3x squared plus 8x and 9x plus 24. So we can take an x out of the first, and we have 3x plus 8. And the second group, we can take out a 3, and we're left with 3x plus 8. And now we have our two factors, x plus 3 and 3x plus 8. And that's what we can go ahead and solve. So we end up with x equals minus 3 or x equals minus 8 over 3. And that's it for grouping. So we'll start with some examples next time to see if you can remember the process and do it yourself. Again, there should be a few of these on the homework to try. And there's plenty of examples in the exercises for 1.4. So are there any questions from anyone? I think it should be a 7. Never mind, he multiplied the LC by 15. So did I get that one correct? Is there a question on one of these problems here? How did I get minus 75 again? I multiplied the 5 times the minus 15 for this one. And down here, 3 times 24 made 72. So when the leading number is not just x squared, you have to start by multiplying the first number by the last number.
I have a question.
Yes, go ahead.
Will we be able to complete homework 2 with what we learned today?
No, definitely not. There's going to be two more sections. That's why I don't know if you looked, but I made the new due date a little bit later. So it's next Friday, the 29th.
Okay, thank you.
And if we don't get everything finished, because it includes exponential and logarithmics, if we don't get through 1/6 or whatever it is, then I'll just push it back a little more as well.
Okay.
So if I started the homework and like didn't finish it, I can go back to it later, right?
Yeah, as long as it's before the due date. Yeah.
I don't see any due dates posted for the first homework assignment. When's that supposed to be?
You just go to WebAssign and it's there. So here, I'll go to WebAssign for you. So if you look, I don't know how I do this in the student view. So if you go to your course, you can see the due date right there. Homework number 2, Friday, January 29th, 11:59. Does that make sense?
Got it.
So when you log in, you should see the dates. I just mentioned that I extended it. So the beginning of this class, there's a lot of stuff to cover. And because we didn't have class on Monday, it just auto-populated the first sets of due dates for me. And, I'll update them as we go through. When is our first test? I'm not sure yet. It'll be a little while. Probably more like week 7 or 8. So quite a ways from now, test 1. Any other questions? If not, then feel free to leave, and I'll stop the recording here.